So thanks everybody for joining Aiven and Lenses today to learn about how to build an open source data platform in the cloud from start to finish in under 60 minutes. Literally during the duration of this webinar, that's what Francesco Tisiot from Aiven, who's a developer advocate with Aiven, and Adamos Lozao will go over. Adamos is a solutions architect at Lenses. So a quick agenda. We're going to give an intro to Aiven and Lenses, what each of these tools are and how they're used together, define what an open source data platform is and why you should care. We'll contextualize why you should care with an intro to Alpha Pizza Ops, which is an application built on this open source data platform. And then we'll get into the underlying platform with Aiven and Lenses, go through a technical demo, get into some next steps and Q&A. So we're going to assume that everyone here has an understanding of open source databases and streaming like Kafka, and that there's some interest and pain points around data operations, security governance, etc. So introducing Aiven, what Aiven does is bring the most popular and proven open source data services under one roof, and we provide them reliably and at scale across the public cloud landscape that you see there. So these are both popular open source systems that have come out of the likes of LinkedIn and also Uber in the case of M3, but also purely open source projects that have been built over the last 3 decades like Postgres. And Lenses is the data operations platform for real-time applications built on Kafka. So you see, kind of the visual here for product development teams and really data platform stakeholders that sit between the actual applications and products being used in the field with the platforms that are powering them that might use Kafka or Postgres, Elasticsearch. They might be cloud native with Kubernetes. Lenses provides monitoring, platform administration, data exploration tooling, very advanced, along with the most mature SQL interface on top of Kafka. And we'll get into that. We'll see it live momentarily. So in short, at a high level, what Aiven does is make Kafka really easy to deploy for our customers. We like to think in terms of kind of bulletproof operations. So high uptime SLA, super reliable, scalable. We take care of the complexity for you. But it's not just Kafka, it's Elasticsearch, it's Postgres, as well as 6 other cloud services. And then on the Lenses side, again, data operations for real-time streaming on Kafka, the most mature SQL interface on Kafka. And what this allows is these complex, it makes complex kind of intercorrelations between data, applications, your infrastructure, a lot easy, not just with the ability to do those things, but actually kind of seeing is believing, visualizing them from a topological view. We can visualize that the 2 tools together. So you see the Aiven services below, a managed data layer for hassle-free Kafka and more, and the data ops portal from Lenses above. So together we are bringing to market and working with customers actively on this open source data platform. So what is this and why should you care? Well, the first is future-proofing your business with open source and with tooling that has been proven at scale. So attract the best talent with the best tech, improve your business and make better decisions by using reliable data infrastructure with a data operations platform that actually makes the data actionable. And then, through the use of these tools, empowering your developers to do those things to focus really on your core business. We will look at a business called Alpha, which is Aiven Lenses Francesco Adamos Pizza Ops. It's the first pizza marketplace in the world, bringing together all the data on pizzerias, their menus, their customers, etc. It's powered by Aiven and Lenses. It's an open source data platform. We help pizza shops make better pizzas faster, tracking and analyzing all of pizza operations for continuous improvement. So we're looking at here an example of two, pizzas, right? All the different toppings, the different pricing schemes, the number of customers, their payments data, etc., where they were, the shop location. So pizza shops actually have a lot of different types of data. You'd be surprised. This data will be streaming through Kafka in real time. We'll store it in different database systems, and then we'll demonstrate Lenses.io layered on top of the system for analytics, security, and governance requirements. In short, we're going to let you, our pizza shop customers, focus on pizza. We're going to take care of the data. You can pretty much insert your business name here and let Lenses and Aiven take care of the data. That's what this demo and presentation will be all about. And with that, I'll turn it over to Francesco.
Okay, let me share my desktop so we can start. So as Andrew said, as of now, we are just thinking about building a data pipeline, and we will see the details a little bit later. And we had to come out with finding a nice set of data that we could use for our pipeline. Initially, we tried to put some like breakfast related data, but as you know, as I will know later, I'm Italian and Adamos is Greek. So we wake up minimum 11 a.m. in the morning. So like any breakfast related thing is not for us. So what we did, we started with pizza. And this will be our demo data set. We will have, as we will see later, a demo app that will start producing fake pizza orders. And for each order, we will have the order ID, the shop receiving the order, the name of the person calling and creating the order together with the phone number, the address, the city, latitude and longitude of the address, as well as the order time in Linux format, the total amount of the order, and the card number. We will see some magic that we will use with Lenses in order to hide a little piece of this number, and also the order details. So we have someone who ordered a margarita with olives, anchovies, and mushrooms, and someone else that ordered a diavola with some sort of questionable topping from my point of view, which is strawberry. But let's not focus on that. Let's focus on the technology. On the architectural overview, what we will start with is just a demo app. Demo app, which was built in Flask. It's a Python app, and it exposed the Python app to the web via Flask. And then this app will start producing nice pizza data to Kafka, to a topic in Kafka. We will take that topic in Kafka and push the data to Elasticsearch, to an index in Elasticsearch. And then, since the data is nicely landed in Elasticsearch, we will create on top a Grafana dashboard. So we will be able to start having a look at the data itself. This first pipeline, however, will not change the original shape of the data. The data will be pushed by the Python application and will reach the Grafana dashboard more or less in the same kind of using the same structure. On the other side, when we need to change the structure, here is where Lenses start making sense. And Adamos, do you want to say something here or?
Sure. So basically the idea is that with the help of Aiven, you can spin up all the infrastructure components and get your data pumping through end to end. And once you've got the data flowing through, then how can you get productive? How can you do business logic, including securing your data, making sure that everybody can see what they're supposed to. So what we're going to show with Lenses is that by putting it on top of your data systems, you can do both real-time transformations as well as control who gets to see what in a democratized way. Yeah.
Okay, so one additional thing that you can do, and we will see later on with Lenses, is to change the shape of the data. And let's say that we don't only want to monitor our dataset with a Grafana dashboard. We may also want to push our data from Kafka to a relational database. If you remember before, our data set was nested. So we had the order details and then a sub-JSON item for each pizza and additional topping. What Lenses can do is to create a flat data structure out of this nested JSON document. And so we can put this nice flat data structure into our database, a relational database that cannot really handle well nested data structures. So this is what we will do at the end. We will add to our example another connection to Postgres. If you check the little icons between Kafka and Elasticsearch and Kafka and Postgres, you will see that they look quite similar to Kafka. What we will use there is a technology that is called Kafka Connect. So we will see that with only a config file and using the power of Aiven, we can replace kind of an ETL system and have everything connected just with few settings in a JSON config file. So now let's start the demo. And now that we start the demo, we want to make this session a little bit interactive. And I believe we want to ask you a few questions during this demo. The first question will be about how you are running Kafka as of now. And you will have the options to decide whether it's on premises, it's cloud self-managed, it's a cloud service that you purchased from a vendor, or if, as of now, you're not using Kafka at all. Just reply while we go on with our demo. And the first thing that we will do is to actually start creating the base structure that we have been talking about. So the first task that the first item that we will create will be our Kafka environment. As you saw, I'm in the Aiven console. I just click on Create New Service, and I select Kafka. I can optionally select one of the versions available. And if I scroll down, Aiven allows me to select which cloud provider to choose between Amazon Cloud, Google Cloud, Azure, DigitalOcean, and UpCloud. And after I've chosen the cloud provider, I can also choose the cloud region. So in this case, I'm fine with the Google Europe West 3 based in Frankfurt. Now it's time to select the plan. The plan drives the amount of resources available to my service and also the related cost. And you can see that we have several different plans, starting with the basic startup to the various business and to the premium. For example, the business 4 that we selected now, it includes a 3-node high availability set, and each node has 1 CPU, 4 gigabytes of RAM, and 600 gigabytes of storage with no backups. It also shows you the cost. The cost per month, it's $660. And this is the total cost. You will not have any further surprise in your bill. You don't have to care about extra network cost. Everything is included with the price that you see here. The last bit that we need to fill is the service name. The service name is the unique identifier of our services, in this case, the Kafka one within our project. And let's call it Kafka Pizza. Well, we will reuse the same suffix for all our services. So now we click on Create Service, and we go into the main project page, and we see that the Kafka Pizza service is going to be started by Aiven. So let's, in the meantime, create other services. So we said we will use Kafka, we will use Elasticsearch. Let's select always Google Cloud. We are fine with Europe West 3 in Frankfurt. It's okay to have a startup plan, for example. And let's say that we call it Elasticsearch Pizza. Let's create this as well. Now we created Kafka and Elasticsearch. It's time now to create the Grafana service. And I'm fine with all the defaults. Let's call it Grafana Pizza and create the service. And the last piece from Aiven point of view will be Postgres. Again, I can choose the version if I want. I could go for the newest version. Let's say that I'm fine with the 12. And also, let's just change the name of Postgres and call it Postgres Pizza. So now I created the 4 main pillars of my infrastructure. What I can do while I wait for the pillars to be in ready mode is to change a little bit of parameters. So I go into the Kafka instance, and first of all, I start enabling some features that Aiven allows me to do. The first one is to enable the REST APIs. The REST APIs will allow me to manage the infrastructure. Just 1 second that I'm seeing an error at this point of view, to manage my infrastructure with just few clicks. So let me try it again. No, that doesn't work well. Let's try in the meantime to add a connection between Grafana and Elasticsearch. If you remember, while we wait for the Kafka bit to be in a better position, we wanted to create a Grafana dashboard on top of Kafka, on top of Elasticsearch, sorry. We can easily do that with the Aiven console, where we go to the Grafana application and we say, manage the integration. In the manage integration, there is a nice data source option that we can use. If we click on data source, we can say to Grafana, please create me a data source for Elasticsearch pointing to the instance Elasticsearch pizza that I just created. So we can now do that. And now the service integration is ready for us to work on. Let's now go back to our Kafka. Let's check the status. Kafka is in running mode. Let's check if we can. There is an error now here. So in the meantime, while we wait for this to fix itself, Adamos, do you want to check for my Flask application?
Yes. All right. So while Francesco has pretty much built the whole infrastructure with a few clicks, which is pretty amazing from zero to hero, let's have a look at what Lenses can offer us in terms of visibility. But before we do that, I've got a question for the audience. So my question for you guys is, how do you currently explore data on Kafka? So I think we've got another poll coming. There we go. So how do you explore the data on Kafka? Is it via command line, like the default option? Do you spin up your own app, maybe a little consumer? Or do you have a UI that you can just go and look at data? So yeah, while you're answering that, let me just share my screen to see what we get with Lenses. So here we go. Lenses is the data ops portal for Kafka. And you can see that there's quite a bit of stuff going on here. And the reason is that Lenses was designed with the experience of our founders working with Kafka. They soon realized that it's one thing to keep your infrastructure up and running. It's a whole other game to do productive business work with it. And for that reason, Lenses tries to offer a holistic view of your data platform that combines the understanding of 4 things together: your infrastructure, your data going through that, your applications working with the data, and finally, your people and teams. So for that reason, you start with the health of your infrastructure. You can see here, we're directly linking to Aiven, its schema registry, its connect clusters. Then we've got the live data view. There's nothing pumping right now. The data, how they're structured, the topics, the schemas, then the applications. And then finally, you've got the people involved. You've got the auditing. Everybody who does something gets recorded, and alerting. And it's really easy to spin Lenses up because it's Kubernetes native. I can actually show you. It's just a simple Helm chart. Let me stop this and share this guy. Yep. So this is my Helm chart. It's quite easy. I've got some basic information, my license, and I'm hooking it up against my Aiven. It's pretty neat. Right, so where do we start? So now that we have our healthy Aiven infrastructure, the first thing is to start pumping data. And for that, we've got the Flask app. Lenses offers you a data and an application catalog. So you can start correlating how applications relate to data. And if we look at our app section right now, let me cut my video. Yeah, it gets a bit weird. All right. If we look at our applications right now, we've got nothing. And that's because there's nothing running. But I can actually register the application that Francesco is going to run so that lenses can start observing it. All you need to do is a REST API call. I've already created a token for my lenses, and I'm introducing the application as a pizza orders producer. It's the first version. Francesco is the owner. We're deploying it on AWS, this one. We're putting some tags and finally some information about its health check. So I'm going to do this. Done. And then I'm going to switch to lenses to see what's happening. Here we go. So it's been brought up, but you can see that it's orange because it's still not running. So I'm going to, yep, go ahead. There we go. It's green. Yeah, and we didn't fake it either. And to show you that we didn't fake it, this is our health check. So if we go here, here we go. We're already pumping pizza orders. And are we really doing it? Well, let's have a look at the data. So now we're switching to our data catalog. And if I have a look here at our pizza orders, we're getting some interesting information. For example, the data is in JSON. It's directly in Kafka. We have some key information about the non-functional aspects of our topic, that we got 3 partitions. We got another copy, the total messages, but also a data governance aspect. Who's the owner? I wrote that. Or tagging, so that I can easily correlate data sets to things. For example, this, we consider it raw because it's just being pumped. It's about pizza. And it's the first level of our pipeline, so we call it bronze. Then we'll get silver and gold. And if you notice, Lenses has already managed to read the data. So let's have a look. We've got the key for our Kafka message and the value. And there's quite a bit of structure here, but actually from the key, I think we're just interested in this ID. And in the value, because it's JSON, we want to be fully explicit. So we also include the struct here, the schema, if anybody wants to parse it properly. But really, the payload is here. You can see that we've got a shop, we've got the location, the credit card number. Ooh, that's pretty sensitive. And pizzas, and they can be multiple. Right, so pretty good. But if we're going to offer this streaming platform to all of our developers and all of our company, it's not great to be able to see credit card numbers. So can we do something about it? Yes. That's where the data policies come into play. So what I can do is I can create a new policy here. I'll call it credit cards. And I'm only going to expose the last 4 characters. I can create a category. I'm going to call this financial. And it's a pretty high impact. I mean, I don't want to steal anybody's cards. So this is the important bit now. Where do we apply this policy, both per dataset level and within a dataset in what fields? So here, I'm going to apply it to anything that contains pizza in terms of a dataset. And then in the field itself, if I remember correctly, the name is card number. Perfect. Okay, we've got our credit card policy. So how does it look if I go in again? Let's see, let's read some data. Perfect. So now it's masked, which means that I can safely go and have teams onboarded, start reading this data, start playing around with the data. And I even have a SQL Studio for people to do that. So for example, I can switch here and I can say, you know what, give me something where maybe the payload, I don't know, total amount is higher than 30. And give me the first 2, just a very quick example. Here we go. Where's the total amount? Here it is, quite a bit. So yes, all of a sudden you have all these tools at your capacity to be productive with data. So since we've got the data pumping in, the next step is to actually pass it on to Elasticsearch to do some cool visualization. And with that, I think Francesco is going to help us. So let me stop sharing.
Yep. Let me go on with my sharing now. So there we are. We have, just to recap on this, so we now have our Kafka Pizza environment up and running. What we want to do is to actually pump the data from Kafka to Elasticsearch. So let me just go into, like in any cooking show, we show things going up live, and then somehow we take some other bits that we pre-cooked and we show to people. So we will do something like that in here as well. So what we will do now is we will start having data within Kafka, and then we will use this framework called Kafka Connect. And by the way, we want now to have an additional poll in order to understand if you are already using Kafka Connect or not. So this third poll will ask you if you're already using Kafka Connect and if you're using it in dev, in prod, or if you are not using it at all. So we are using Kafka Connect. In this case, it's a separate instance, but it could be in the same Kafka instance, in the same main Kafka instance. And what we will do is, in this case, we already have a connector, but we can easily create a connector. We can check that the connector is running. And when you create a connector, usually what you do is you start filling all the parameters. You start filling all the parameters by hand in order to tell to Kafka, this is the Elasticsearch instance that you have to fill, and a lot of other details. On the other side, if you have a JSON, a pre-formatted JSON configuration file, you can also copy and paste the JSON file into our console. And when you, in this case, I'm editing, if you copy and paste and click apply, what Aiven does, it will basically parse the JSON document and fill all the parameters for you. So like in this case, we are creating a Kafka Elasticsearch sync named connector of type Elasticsearch sync connector. Both the key and the value are in JSON format. And what I'm going to send to Elasticsearch is a topic called pizza orders. Other properties are the connector itself, which is pointing to Elasticsearch, the Elasticsearch instance that we just created, connecting with the username Aiven admin and the related password. And there are a lot of other parameters that we can fill. We can also define some data conversion if we want. And we can also add extra information and extra custom configuration. Once we start the connector, Kafka Connect will start pumping data from the Kafka topic to Elasticsearch. So if we go to the Elasticsearch, we will be able to see the index pizza orders there. And it's the number of documents should be raising over and over again. So the last bit that we were missing in our first pipeline was to show also Grafana. Grafana has the ability to create dashboards on top of various data sources. And one of the settings that we did earlier was to set Grafana to hook up to Elasticsearch. So if we go into Grafana now, first of all, we can see a few things that are common to all the Aiven services. The first thing that we can see is the upgrade plan option. So if we foresee that tomorrow we will have a peak of traffic in our Grafana or Kafka or Elasticsearch environment, we can easily upgrade the service to a bigger plan or to a smaller node if we don't foresee a lot of traffic in the next few days. For a lot of services, this upgrade and downgrade will happen while the service is online. The same goes with Migrate Cloud. I can change the region where my Grafana, my Kafka, my Elasticsearch, my Postgres instance is running. And for a lot of services, this region migration or even cloud migration will happen while the service is online. So there will be no downtime. So we said that we have Grafana, and we can access Grafana via the service URI that we can copy and paste in our browser. Now we can take the ABN admin user, which is the default user, and the related password and log in. And one thing that we did before was telling through the console to Grafana, please create me a data source for Elasticsearch. If we now go to the data sources, here we see that it's real. We have the Aiven Elasticsearch data source pointing to the correct Elasticsearch instance with all the username and password, with all the credential properly filled. The one thing that we need to add in most of the cases is we will need to tell to Grafana, please use the precise index that we created in Elasticsearch. In this case, since we are in kind of the cooking show, we pre-created this demo, the index is already filled. So we have the pizza order field we need to change the time field name, which is order time, and we need to change the version to 7x. Now we save and test, and we should be good to go. If we now explore the data, we can see the data flowing. And these are all pizza orders flowing. The other beauty of Grafana is that we can create dashboards. And we can either create dashboards by hand, or if we create a dashboard earlier, we can import that dashboard in our Grafana instance. So if I find now the dashboard in my documents, there we are. It's a JSON file. Let me change the UID of the dashboard. And the other settings that I need to create is I need to tell to the dashboard, please use my Aiven Elasticsearch is the lenses demo. Once I import and override the dashboard, now I will be able to start seeing all the metrics of all the pizzas arriving in the last 30 minutes. So the map probably is not showing because it has filters for the last few seconds, which are not arrived yet. But if I apply this, I should see data flowing for, as you can see, for the last 30 minutes, or I can change the filter to be only on the last 5 minutes. And I can see data about the pizza orders in all the zones of Milan and the other cities around Milan. I can start checking the total number of orders and the orders per city, as well as details, for example, on the pizza selection, checking that, for example, I believe Margherita is the one having more orders. And also like some nice visualization around the order amount and the max order value. So as you can see here, with just one configuration file, we were able to push the data from Kafka to Elasticsearch, and we were able to create a nice dashboard in Grafana pointing to the Elasticsearch data without having to change any shape of the data. Now, this is the first pipeline. Let's go to lenses in order to make some more transformation. And Amos, up to you.
Nice. I have to say, I wasn't very excited that Margarita was number one. I was hoping Diavola would be, but it's okay.
Yeah, everything is better than the one with strawberries, from my opinion.
Yeah.
But, yeah.
What about the Hawaiian one?
Not start talking about that, please.
All right. Okay. So let's have a look at what's happening on lenses. But again, before we do, we've got another question for you guys. So in general, if you're dealing with Kafka, how do you like to process your Kafka data? Do you tend to do it in patch mode? So you send your Kafka data off of Kafka into something like a data lake and you process them there? Or do you tend to go directly stream mode where you're reacting to the events as they come? And there's a good reason we are asking that, because we're about to see what lenses can do to it. So here we can see that our dashboard has slightly changed because, of course, we've got data flowing through, thanks to Aiven and to the Flask app generating stuff. And we saw that Francesco has connected Kafka to Elasticsearch. And what does that mean for our end-to-end topology? So here, actually, we can see the bits being connected. We've got the Flask Python application generating data to this topic, the pizza orders. And from there, the data is being picked up by the Elasticsearch connector that Francesco set up, and it's shipping it off to Elasticsearch. So now we have two places where data sits. We've got the Kafka side and we've got the Elasticsearch side. So what if we want to see both? What if we want to understand what the relationship is? So this is, again, part of the DataOps vision. Let me just cut again the camera. So we saw that we can access the Kafka topics, but actually, I can also look at Elasticsearch. So I can see if we're actually telling the truth. So here we go. We've got the index where the data is being pumped. You can see, again, we have interesting information here about its size, its status, and data governance. And we can access directly the index. So the data is as it's supposed to be, but also you see that the masking is still applied. So no matter the data system, you can search and look across and you'll still get the same experience. What's even more, you can even start querying things. So if you go again to the SQL Studio and you select maybe just this guy, yep, here we go. There we go. You can start asking questions on your Elasticsearch and on your Kafka, and you can start comparing things. Great. Now, the next step we want to do is to actually change a little bit the data because we want to ship them eventually to Postgres, again, powered by Aiven. But there is a little problem because if we look at the data here, let me see if I can, yeah, this one. So for each event, we actually have multiple pizzas. So it's a nested structure. And trying to fit the nested structure into a relational database that operates on a row level, it's not that easy. So ideally, what we'd like to do is to go from one event, which can contain multiple pizzas, into a separate event per pizza. How can we do that? Well, this is where the SQL processors come into play from Lenses, because you can actually do streaming applications with very low code, just with SQL, and it's Kubernetes native, so you don't have to worry about a separate flavor of infrastructure. So how do we do this? Well, let me try and flick to the data so we can start comparing what we're doing. In the meantime, I'll create a new processor here. I'm gonna call it order to pizzas. For now, I'll run with one runner. And what I'm gonna do is I'm going to pre-populate it with some settings. Here we go, just to create something with 4 partitions and so on. So let me take a look at the data again to see what we wanna do. I'll get rid of this guy. All right. So what we wanna do is first simplify a bit. So from the key side, we don't care about all this noise. We just wanna get this guy. And from the value, we don't care about the schema. We just care about the payload. So first, let's try and wrangle the data a bit. So to do this, we can create an intermediate definition for our SQL, this one. So we're naming it wrangled. And what's happening is we're selecting the stream from pizza orders, which is a topic. Remember, we're operating on Kafka. And from the key, we're just taking the payload ID and we're naming it as key. It's going to become the new key of the output. And from the value, we're just picking the payload. So what we should end up is just this guy and this guy. Perfect. Now that we have those two, what do we want to do next? We want to take all these columns, but for this pizza part, we want to do an explosion or a lateral join, as it's called, where basically for each entry, you create a whole new event that contains the ID and the existing columns. So one of the neat tricks that the Lenses SQL engine can do, let me paste it here, is the lateral join. So the next bit, which we're going to call exploded, is going to select the output from this guy. It's going to pick all the columns that we care. And then what it's going to do is going to take the pizzas and explode them as pizza entry. And from there, we're only going to pick the pizza name. Because if you look back, you'll see that for each pizza, we've got quite a few things. We've got the pizza name, but also toppings, and we don't care about the toppings. Perfect. So we got all the data we need. Now the last bit is just to actually insert it. So all I need to do is say insert, and then select everything from the last definition, from the exploded one. Great. Now, there's one more trick that we can do here, because if we pay attention, the input data is JSON. Why? Because it's a Flask app, it's a microservice, it talks JSON pretty well. But when it comes to streaming and the Kafka platform, it's much better to have a more intelligent and optimized format such as Avro, which allows you to first optimize the space that each event requires, and also to evolve your schemas so that you can add fields without breaking your compatibility. So if I just write it like this, it's gonna create JSON data, but I wanna create Avro. Turns out that Lenses can do this adaptation, change the format automatically using the Aiven schema registry to register the output schema in one line. So what we're saying here is keep the key as string and the value as Avro. All that we're left with is deploy it on Kubernetes. So I'm working on Amazon EKS, but you can work on any kind of Kubernetes. I'm gonna ship it on this namespace. And finally, let me just add an ID here. There we go, and off to creating it. Great, so it's still not running, but you can see that it's already picked up the types of transformations that it needs to do in between. It uses the full Kafka streams semantics. And now all that is left is to kick it off. All right, so what's happening under the hood, Lenses communicates with my Kubernetes cluster. It's got already a pod running, but I'm feeling pretty good, so I'm gonna push it up to 4, because that's the point of having things on Kubernetes, that they can be elastic. So you can see 3 more pods are coming up. Perfect. So then what does that mean? Let's look at our topology. Here we go. It's a bit more involved now. We still have our Flask app pumping data to the pizza orders, but now we've got the SQL processor that's taking that data as it comes, streaming it to another topic, the pizza orders flat. And do we have any data? Let's have a look. All right, so now we've got the flat, and you can see that it's different. We now have a string type, much simpler type for the key because you only have an ID, and a full Avro for the value. You can see that Lenses can still visualize it as before. We're still masking the sensitive data. It's quite a simpler structure, ready to be pumped to Postgres. And you can also visualize it as a table, which is very nice. It's almost like we're ready to go to Postgres. And finally, so that you don't take my word for it, Lenses has created a schema using the Aiven schema registry. So if I look for pizza, here it is. You can see that it's pre-populated. So everything is integrated. Great. So we're in a pretty good position, I think, now to actually pump the data to Postgres. So what we need is another connector. And for that, Francesco is the man.
Yep. So, okay. So now we have our flat, perfectly flat pizza orders structure. So what we are going to do next is to create a new connector. Just to show you that I'm not lying to you all, what I will show you now is actually the Postgres database that we created before. I have a connection in dbweaver to it, and I can check that there is a default DB within it. There are several schemas. Within the schemas, there is the public schema, and there are no tables in it. So what I will do now, I will go to Aiven console, and I will check out my connect, and I will create a new connector. Let's create a new connector. Before we created an Elasticsearch sink. Sink is the terminology where you want to create a connector from Kafka to a target application or data store or what else. In this case, since the target is a Postgres database, I will use the JDBC sync. So let's click on it. And again, as before, we have the option to select and to change a lot of the parameters in here. Like before it was already pre-filled because it was an existing connector. In this case, I will edit the JSON configuration and I will copy paste a configuration that I pre-created. When I click on apply, Aiven console will populate all the fields based on the content of my JSON file. So in this case, I'm creating a connector with name pgsync. The type is a JDBC sync connector. And as Adamos was showing before, we have a string as a key and a arrow as a value. And the topic from Kafka that we are going to push to Postgres is called pizza orders flat. On the database side, we have the connection, the JDBC connection to our Postgres application with JDBC user and password field. And the other bit that we want to do, because we are lazy, we don't want to create the table ourselves. We want the Kafka Connect to also create the table for us. So we enable the auto create option. So now if we click on create new connector, now we see that there is a new connector called pgsync as we defined before, and it's running. Just wait a couple of seconds, shouldn't fail. Let's go and check on the database how this is going. If we now refresh the set of tables, okay, look, we have a pizza orders flat table. If we double click on it, we can see all the data. So the connector created the table and started pumping data into it. If now I just write a simple select statement to count the rows, I execute it now, I see 2 million rows. If I re-execute it, I see the counter going up. So this means that Kafka Connect created a table, started pumping rows, and it will continue pumping rows as soon as they land in the flat topic. So we have a full data pipeline built with just configuration files. And now, do you want to show us something more on the Lenses side, Adamos?
Yep. So let me share my screen. One sec. So we've managed to connect a lot of dots together, and it's always great to be able to visualize and see what's what. And we can see here in the Lenses topology that, again, the ecosystem is growing. We started from the original Flask app that's pumping data to pizza orders. Then we wrote the SQL processor that's writing to another topic, and off it goes now to the Postgres sync connector and reaching Postgres. So you can see now we've got this 360 understanding of all of our streaming platform, and we managed to do this in less than an hour. So that's pretty good. But while we're about to look at some data, I wanted to show you that Lenses also gives you alerting capabilities. So one of the very important things when it comes to streaming is time, because everything keeps flowing. So an important aspect is to be able to understand the production patterns of your data. Lenses allows you to have a better understanding because it has alerting based on thresholds for production rates. So what I'm going to try and do here is I'm going to try and set an alert on our original topic, the raw topic, to make sure that if the production drops, we get to know about it. So here we are in the pizza order section. And if I go to metrics, you can see that we're already capturing metrics on what's happening. And I'm going to try and create a very easy rule to break just so that we see what's happening. So if I receive less than 10 messages per minute, and here we go, I want to know, and I'm going to send to my Slack. So I'm going to create this, and I'm going to ask Francesco to just kill the Flask app just for a bit so we can see what happens. Perfect. And in the meantime, what I want to show you is that again, the data ops vision, the idea that you can understand data across the board. So now we also have access to Postgres. And if we look here, yep, we're already getting close to 9 million records. Well, actually more than that. I've put myself as an OR this time. Why not? And we're putting some tags. For example, this is a DB. It's a silver level data set, as in it's progressed down the pipeline, and it's still about pizza. And of course, you'll notice we're still masking the data. So no matter where you access it from, it's always masked. Great. So let's see what's happening here. Let me see if we got on our alert first. Let me just check. It's coming. Maybe as soon as it comes, I can actually share my screen. Let me kill my video again. All right. So I think we can do a recap. And as soon as the alert comes, I can share my screen again.
Yep. So let me take control and go back to the recap. So this was our demo. We started by having our Flask app, and within minutes, we were able to create an environment from Aiven point of view, which was including Kafka, Elasticsearch, Grafana, and also Postgres. Not only those pieces together, we also managed to connect all the dots. So we managed to create a flow with Kafka Connect that was taking data from a Kafka topic and pushing them into an index in Elasticsearch. We were able, from Grafana, to set up automatically a connection to Elasticsearch. And by changing just the references to the index that we wanted to query, we were able in minutes to create a dashboard on top of our data. Then we also did some magic with lenses that Adamos will talk you about later. But also, once we had the topic in a structure that was okay to be stored in a relation database, again, with the power of Kafka Connect, and only by setting a config file, only by setting few items in a web page, possibly, we were able to start pushing data to it and achieve real-time reporting, real-time dashboarding on top of our data that was landed in Kafka. And then we did a lot of magic in lenses, and that's up to you, Adamos.
Yep. So with the help of the Aiven infrastructure, the services, getting them easily up and running, then we put lenses on top, which allows you, to understand your data, to be able to understand the relationship of data across all of those data systems, to be able to govern them with masking, with metadata. And actually, the other thing I wanted to show you, if I can share my screen for 1 sec, is that actually we also got a real-time data catalog. And here, if I want to understand, let me do that again. So here I've got all of my data sets. And if I type card, you'll see that I'm understanding immediately the exposure of card numbers across my systems. And that's because Lenses correlates the schemas with your data sets, and it gives you an order of magnitude more visibility. So then we saw how we can help your streaming platform with doing real-time transformations with low-code SQL. And finally, we can also do alerting. So the alert actually came on my Slack, and here it is. So you can see this came directly from the alerts. Basically, the app was killed. So we actually got 0 messages in that minute, and we got alerted directly. So yeah, so the general idea is that with the help of the DataOps portal lenses, you can start becoming extremely productive with all these modern technologies while still remaining in the context of streaming. And I think with that, we've covered quite a lot of ground. So we can maybe move to the next steps. Yeah.
Yep. So little virtual round of applause, I think, for Adamos and Francesco. Great job, guys. And thanks to everyone that joined today. As far as next steps, first, especially given the current times, let's support our local pizza businesses, right? It's about lunchtime here in Manhattan, so um, I will be getting pizza maybe for lunch. We also have a last poll question here after this session demonstrating this end-to-end data pipeline implementation. How likely are you to use Apache Kafka in the future? Thanks for everyone's participation there. Really easy to get started with Kafka on Aiven and lenses. Following the link that you see there, lenses.io/cloud/Aiven, and we'll also have this recording made available. You can, when you go to sign up for a trial of Aiven, use the code lenses2021 for $500 in trial credits. And all of the data that you saw setting up the Python Flask application is open sourced, courtesy of Francesco. And Lenses also has many resources, including the one we've linked there for ways to use Lenses to explore that data. So you could recreate this demo yourselves. Next, Francesco, we'll turn it over Q&A. We have about 2 minutes. We can probably go a little longer than that, but thanks again, everybody, and please ask away.
In the meantime, I'm wondering if we could show the polling results if we have them. That might be interesting.
Yeah, defer to Emma.
All right. So how are we running Kafka? Okay, so quite a few people are not using Kafka, so I'm guessing you guys might be interested in using Kafka, right? Cloud service, but only 19 self-managed. Nice.
Yeah, well, there is still like over 30% of either on-premise or self-managed. So it's quite a good portion.
All right, how are you exploring data on Apache Kafka? Quite a bit on command line, even more spinning your own app. Oof, man, yeah, writing code for it. Been there, it's pretty tiring. And less on using a UI. All right, well, hopefully now you have an alternative. Just saying,
we actually do, just before we keep going on the Q&A, we have
few,
we have a number of questions coming in on the Q&A.
Let's review all the polls and then we go over to the Q&A.
Sure, you got it.
And then the final one,
Apache Connect. That's interesting. Over 60% of people are not using Apache Kafka Connect, which I believe it means that even if they are using Kafka, they are not using Kafka with the full power, because Kafka Connect is actually really useful if you don't want to write yourself every time the code to push data to Kafka and to pull it.
And then finally, batch versus streaming. Wow, this is very good. I was expecting most people to go for batch. That's very encouraging, guys. That's really cool. Yeah, I'd be interested to see if you do it with using the Kafka streams or Spark streaming. Yeah.
Okay, and then we have majority of people already using Kafka, and at least we have few people that are likely to start using it in the near future or in the future as well. That's good to know. Okay, off to the questions.
Yep. So the first question from an anonymous attendee is, can I automate SQL processors against Lenses?
Yes, you can. So Lenses follows a GitOps approach. So basically anything and everything that you saw me pointing and clicking, there's a REST API behind and a Lenses CLI. You can export things as YAML, import them as YAML. So basically you can drive everything as code. Yep.
Okay. From Olivier Lorette, how easy it is to ingest unstructured data, logs, for instance. I'm not sure if that means into Kafka or Lenses, but yeah.
Yeah, in Kafka has a notion of key and value. And key can be anything you want, and value can be anything you want. So if unstructured data, logs is, from my point of view, somehow structured data because it will have a timestamp, it will have a log name that you can reference, it will have somehow the meaning of what component was giving the warning, or if it was a warning or an error. So, but Kafka really doesn't care. If you want to put whatever data you want, you can do that. Then, of course, the more it doesn't have the structure, the more hard will be to start reading and making sense of it. But it's the same, if you take my words, schema on read paradigm. You can push whatever data you want to Kafka, and then you will have to make sense of them at a certain point. And I believe lenses is a good way of understanding the shape of the data that you have in Kafka and start transforming it.
Mm-hmm. Yep, it's pretty fair. So basically, yeah, because Kafka just doesn't care what you put in it, you can pretty much pump whatever you want, structured, semi-structured, unstructured, and then you get to decide later how you want to interpret it. So that's the idea. Yeah.
Great. Next question from Sagun Garg. There's actually a couple. Is there a Helm chart installation for lenses?
Yep.
EKS Helm plus Helm chart plus lenses installation step-by-step blog.
Yep. So we do have the basic documentation for installing it on Helm, but we're working on providing one specific for EKS and including Fargate.
Okay. Next is from Mikhail Kuma. Any examples of advanced alerting in lenses?
Right. So what do you mean by advanced? Can you give us an example? Maybe we can open the mic or something.
Yeah, perhaps. Is Mikhail still on? Yeah, can we unmute Mikhail?
Yeah, does this work?
Yep.
All right. So alerting based on the value content. So perhaps on the value of a field.
Right. So if that field is, I don't know, red, then ship an alert, right?
Yeah.
Mm-hmm. Yep. So actually this is coming because it's the foundation of creating such an alert is you need a processing framework, an engine that starts reading the data and then reacting to it, which is what the SQL engine is for. So in the upcoming versions, what you're going to see is that ability. You can express your alerting criteria in SQL, basically select everything where thing is red, and then alert to something like Slack. So that's definitely coming.
Thank you.
Cool.
All right. Oh, I saw Mikhail said based on content. So Sagun had another question. Are there any early stage startup credits with Aiven, like Confluent offers $10,000 alert? For Aiven's part, we don't, well, we can talk offline, Sagun, but everybody that comes in gets started with a base level of credits, and for our esteemed, users of both lenses and Aiven, they can get started with that lenses 2021 code for $500 in credit. But as far as startup credits as a program, we don't have anything currently, but happy to chat offline.
Yeah, just to add to that, from the host, we will probably be looking into establishing an Aiven startup program in the near to midterm future. So stay tuned, but we don't have anything yet, as Andrew pointed out.
Great. Two more here. What is the difference between lenses and Aiven? Are they two different companies? So I'll take this one because I failed to actually introduce myself when I kicked off the presentation. I'm the partner sales manager here at Aiven for the Americas, and I work closely with Olivier de Gerges from Lenses, who's my counterpart. So we're partners, strategic partners. We work very closely together, and Lenses helps Aiven customers and Aiven users of Kafka, Elasticsearch, Postgres get more value out of those tools. And we help keep Kafka up and running so that they can use Lenses day in and day out without any issues. And then Another question from Gabrielle. Seems Lenses integrates with Aiven and the other way around, so I need to help understand. So you'll first have data in Aiven, layer Lenses on top of that. I don't know if Adamos, you'd like to elaborate. But
Yeah, I mean, the way I like to think of Lens and Aiven is like if you ever liked the old school Formula One, Williams Renault. You've got two teams coming from different places, but it's the combo that makes the winning argument. So Aiven brings you data infrastructure as a service. As you saw, Francesco just pointed, clicked, and you've got full production ready Kafka, Elasticsearch, Postgres on the cloud, any cloud. And then you put Lenses on top, and all of a sudden you can do work on top of these systems. So it's the winning combo, basically. Yeah.
Okay. Thank you very much, everybody. Hope to see you soon.
Thanks, guys.